Welcome to my YouTube channel. Kindly subscribe, like, and share. Today we still continue with our series of examples on the tangents and normals using calculus. So the question says, find the equation of the normal to the curve y equals 2 over 1 minus 2x at the point where x is equal to 1. All right. So our original function, y is equal to 2 over 1 minus 2x. Now, let's just try to rewrite this function. We can say this is y is equal to 2. This one is the denominator. We can take it on top by saying 1 minus 2x to the power negative 1. Like that. So, just looking at the function, this calls for chain rule if we are to solve. So the chain rule, that is just the dy dx is equal to dy du times du dx. This is the chain rule. That's the formula that we are supposed to use. So now here we'll say let this function in the brackets, we'll let it be u. So let u be equal to 1 minus 2x. Then if we do that, our y function will simply be equal to 2u to the power negative 1. Then we can differentiate separately, and that is du. We are differentiating u with respect to x. That is equal to negative 2. Then here, we differentiate y with respect to u. So dy du, and that gives us the negative 2 u. Negative 1 minus 1 is simply negative 2. Okay, so that's what we will have. And then if we apply the formula, our dy dx will simply be dy du, that is negative 2u to the power negative 2. Then times, we multiply it with this one, that's negative 2. And it gives us the positive 4 u to the power negative 2, of which this can still be written as 4 over u squared. Now, we bring back our u, which is 1 minus x. So dy dx is simply equal to 4 over 1 minus 2, where is it? Okay, 2x to the power 2, like that. So this one is the gradient function. Then having done that, all we need to do is find the gradient at x is equal to 1. That's the gradient of the tangent. Then we use it to find the gradient of the normal. So dy dx at x is equal to 1, that is 4 over 1 minus 2, and then here we put 1, then we square, that gives us 4 over, this will still be 1, so that's just negative 1, yeah, but we are squaring it, 4 over 1, which eventually becomes 4. So the gradient of the tangent is simply 4. And then the gradient of the normal, that's negative 1 over dy dx. This will give us negative 1 over 4. So we can keep this gradient. But since we want the equation of the normal, we still need the y value at that point where x is equal to 1. So we use the original function. Y is equal to 2 over 1 minus 2x. We use this one and substitute the x value, which is 1. So that gives us y is equal to 2 over 1 minus 2 times 1. This is just 2, 1 minus 2. So that simply gives us negative 1 here, which is just negative 2 as the y coordinate. So the point we are talking about is simply the point is 1, negative 2. So now using this one, we can find the equation for the normal. Y minus y1 is equal to mx minus x1. You can use this formula to find the equation. So we now say y is equal to our y1. We pick y from this point, which is minus 2, is equal to the gradient that we found for the normal was negative 1 over 4. Then x, the x value, okay, it's 1, minus 1. So this gives us y is equal to negative, if we multiply here, 1 over 4 x, and then this and that gives us positive quarter. Then this one is positive here, but there will be negative, so minus 2. So we can just work out a quarter minus 2. That gives us 1, this is 4, 8. That's negative 7 over 4. So y is equal to negative 1 over 4 x, and then minus 7 over 4 as the equation of the normal. This one can still be written as the x. Let's see, the common denominator is 4, it will cross multiply, okay, plus 4y is equal to negative 7. So this is the same function. So you can write it in whichever form. Thank you for watching, and goodbye.